Good day everybody and welcome back to the channel. My apologies, but I lost the intro segment for this video. I imagine from what I can tell looking at it, all I was going to say is that in this video we're going to make up these transformers as they are now made up, and that I had to go over some stuff on the fan control boards. So without further ado, I will let the rest of the video continue. I've just realised something that's not too fun for me, but it is what it is. When I assembled these fan controllers, I had a 1K resistor up the top that was supposed to be a 10, so I put the 1K away and got a 10. But now, I don't know, was that 1K the one off the breadboard and it was a 1K? Like, I actually don't know where that 1K came from. Was it the one that I had sitting here off to the side whilst I was prototyping the circuit, or was it the one from the circuit and I thought it was a 10K but it was a 1K the whole time? I don't know. So we're going to have to check this out. There's no other way to answer that question. I mean, I've tried doing the math on it and I'm a little bit shit at math. What we have is 15 volts going down a resistor that we think is 10K into an NTC, which starts at 120K and ends up as low as, say, a K. Could be lower, but let's just say a K. Just even 2. I've seen the fan come on with it around 2K, so let's assume 2K for the sake of maths, because the fan does come on around there. I think I might be getting that confused with me just looking at it, taking measurements. Oh well, and then that's why this is hard to work out. Then there's the bottom resistor that goes to ground, and it's 2.2K. We know that 100%. So if you try and work, and the point that goes to the transistor is this point here, to the base. So if you try, let's just imagine this is 2K, 2.2K, 2K, 2K, 10K, in between 15 and 0. Well, around there you'd have what, 7, 8 volts, 8 volts, 9 volts, probably around 6 volts here, something like that. See what I mean? My maths is really bad. I guess, you know what, if that was a 1K, it would be an even higher voltage here. Actually, the voltage here needs to be high enough for the pass element to be driven. You know what? I can't be bothered trying to work this out. I'm just going to just power it up and see if it works. It's either going to work or it's not, and I'm going to have to change the resistor. But I'll tell you now, if that's the case and I have to change that resistor, I'm going to be changing probably more than just that resistor. I'll be changing the other one, because I want a fairly high value in between the positive rail and the NTC, so that when the NTC falls in value, there's still, you know, about 10K between the positive rail and the base terminal, which means that the bottom resistor might have to increase quite some bit in value if the top resistor was 1K. Anyway, I'm going to bed now. It's actually a miracle. It's 12:17 and I'm actually starting to get tired, so I'm not doing this tonight. I'm just going to leave this here on my desk so I know to check it first thing in the morning when I come in here. But we'll do that, and then basically what I'm going to do, I've already thought about how this is going to get laid out. I'm going to shorten these up a little bit and fold them all back in and lay this board under them, if that makes sense. Of course it makes sense. Sort of like that. So I'm only going to cut that little bit off, you know. It'll have about that much left. And then that's going to be, oh sorry, for the secondary, I'm going to do that. The primary, I'm going to also bend them in this way. I'm going to heat shrink everything and solder these to some bits of wire, but I'm going to sort of like, I haven't even worked out how I'm going to mount this thing down yet. I don't know what sort of bracket mounts this down. I certainly don't have it, and I can't remember what was holding this down, which is really silly of me. I should have kept it, but anyway. So I got to devise a way of mounting it. I also got to devise a way of attaching these boards and the wires that I solder to get the power into it down to something securely, because I don't want everything that's flapping in the breeze. So yeah, that's going to be the most time consuming part of building the power supply. Everything else, apart from checking the resistor values on this and potentially having to decide one of them again, everything else is straightforward and ready to do. So all right, I'm off to bed. Okay, so I've just assembled one of these fan controllers. I've just got the NTC hanging off the side, 2 fans hooked up, because the circuit is dependent on the load that's hooked up to it. So if the load is slightly different, the resistor values would have to be changed. I'll bring 18 volts over. That'll be enough for the forward voltage on the bridge and the dropout voltage on the regulator, because we just got DC here. Alright, I was just checking that initial spark was just the capacitor charging up, not some sort of a short, and it was just the capacitor charging up, so that's good. I was having a think about this, and I suspect the circuit might work just as good with a 10k or a 1k, but for safety, to protect the base current going into the 549, it needs to be a 10k. But what I'm trying to say is, I'm not so sure that doing this test is going to yield any light, but if it works with the 10k in here, then we're good anyway. What? I'm a little bit confused. How on earth does that not work? You just visually inspect everything. Oh, what have I done? Maybe it was a 1k resistor and that's why it's not working. Yeah, the circuitry is definitely right. Must have been a 1k resistor. Yeah, my power supply is definitely on. Damn it. That means I've got to do a bit of redesigning, unfortunately, which is annoying. It also explains why my circuit was consuming more power than I expected it to. Okay, well, I was going to change this bottom resistor for a pot anyway, just so that when it's in circuit it can be fine-tuned. I'll still fit a fixed value resistor in there for the final thing, because I don't want it to change value and change the thermal performance of the system and then ruin the amplifier. Same reason as why the bias pot only is able to adjust a small range in the bias. so if the pot fails, the bias doesn't get, it doesn't run away. So, oh, I can't believe I've done that. Let's just prove that quickly. Alright, I've got a 1K resistor here. Oh, what am I doing? Wrong end. Alright, let's try that again. Yeah. Actually, let me turn this heat down to 100 degrees because it's at 420 right now and I can't hold on there for too long. That doesn't seem right, actually. The hell? Those fans are barely going. That makes no sense. Everything else on this board's done right. What on earth are we missing now? What could possibly be wrong now? Rail voltage is 15. What? Yeah, it's not a rail voltage problem. Okay, something's up. What have I done? I'm just checking my wiring. I've looked at it 3 times and it's definitely correct. Other than the 10K being an incorrect value. Having a 1K in parallel with the 10K isn't going to make it not work. It's going to make it turn on more earlier. So there is no reason why this is not working. The whole front of the circuit, the voltage regulator, the caps, rectifier, that's all working. We've got the 15 volts. The 2 transistors are hooked up together, correct? And, the little one's turning the big one on and it's passing current, but I don't understand why I'm missing all my power. Oh man, there's something I'm missing here. There has to be. The thermistor? Surely not. Because when I had it on breadboard, I tested both of these regulators and both the transistors, so I don't even suspect that. This has got me puzzled. I don't, the annoying thing is I don't understand what's going on here. It's so simple and everything seems correct. I don't see why it's not working. Alright, let's start measuring voltages. So you know what? That should be working. What on earth? Okay, now I'm really confused. That's pretty much the same voltage I had it at on the breadboard, the base junction, for it to be turned off. And it's turning on and off at the same time, sort of. It's just not coming up to speed. Actually, no, that is taking a lot longer to come on. Yeah, a lot longer. We've still got power. Oh, I've taken the resistor off. What am I doing? Let's just do this one more time. I'm confused how on earth that's not working, especially with the 1K resistor added here. Wait, don't tell me this is not a 1K. No, that's 1K. Maybe the 1K wasn't making contact because of flux. No. That is so odd. I know the bottom resistor is definitely 2.2K, and that's what I've got on there. I was sure the top resistor was 10K, and I had a 10K and a 1K on the bench in the end, so it could have only been one of the two. I cannot explain what's going on here. The only variable is that that's not the NTC I built it with. I really don't see how there could be that much difference between NTCs. That would be a really bad thing if there is for my circuit design. Let's grab the one that we were using. These are both brand new 100K NTCs that I've got from Jaycar. I've got a pile of these and some 20 ohm ones, obviously, for two very different things. Good enough. Alright, well, without further ado, let's try it again. Well, that's reassuring for my circuit design. What do I do now? Try the other board? I've got a funny feeling it's something to do with the resistor, but what on earth did I have on there then? I mean, I'll go back and rewatch my video. It's all I can do, really, and see if I can pick up what I've done. That's all I need, yeah. Let's just give this one a try. Alright, well, that's another one temporarily assembled, so let's see. Oh yeah, I need to put the resistor on here. That's definitely a 10K that's on there too. I can see the red band. Alright. Bring power back in. Didn't hear a spark when the capacitor charged up. But apparently it did. That one's 15.13. Interesting. What do we have here? Alright, this is really odd. Could the 2.2, no, the 2.2K we measured, that's right. I remember getting the pot, soldering the pot, putting the pot in the breadboard, measuring it. The 2K2 was definitely a 2K2. What on earth is going on here? And yes, I've got the resistor going from positive rail to one leg of the NTC, and then the other leg of the NTC goes to the base and also has the 2.2K resistor to ground, which is exactly how it goes. Like 100%, that's how it goes. The emitter's going to the base of the pass transistor, the collectors are tied together. There's literally nothing wrong. Emitter goes to the fan. I am so confused. Like, I don't even know where to start. I'm just going to have to stop this and go and watch the video. This is the most oddest thing ever. Okay. You'd think it was just a 1K resistor, but apparently no, there's something else. My life. Alright. This is actually quite funny. So, I can't remember the exact moment it came to me, but I was just sitting down and I was thinking about the resistor values, because the 2.2K has to be a 2.2, and let's face it, the top resistor's got to be a 1 or a 10. I didn't have any other resistors. And then it hit me. This fan is supposed to go in the collector path between the positive rail and the collector pin, and the emitter goes straight to ground, so the transistor can go into full saturation. I've put the fan between the emitter and ground. So that's why the circuit's still working, but it's not behaving correct in terms of output voltage. So, now I need to come up with a way of rectifying it. It might not actually be that hard. I ran a little red wire from the collector of the drive transistor to power the collector of this transistor, because I couldn't fit a trace there. It's a little jumper. And if I take that out, that opens the collector and positive path. And then if I move the jumper to the emitter to ground location, and then put the fan where the jumper was, that's all I've got to do. So honestly, I can't complain too much. If I was going to complain, I'd complain about the fact that I had to already put one jumper on this. I can't complain because I'm only moving the jumper, so it's still going to have a total of one jumper. Just grabbing some water from my soldering sponge because it's dry. There's probably way too much water, but oh, better to be too wet than too dry. So, yeah. Let's see if I'm right. I'm sure that's what it is. I'm 100% certain. I've had a good look. Nothing was in the wrong place. It's just this one thing. No wonder I didn't notice it when I was looking for an error, because there's not really an error in the circuit, so to speak. It's like you could drive the fan between the emitter and ground, or between positive and the collector. So looking at it from a circuit point of view, it is a correct circuit. It's just not going to function correctly with the given voltage and resistor values that I've chosen. Anyway, at least the fix is simple. So I should be able to just move that across over to ground here. Good. I need something to hold the wire down. Alright, now it's soldered, I can give it a little bend and it won't move again. I'm just going to flow a little bit more solder on the other end of it too. It's not the best joint anymore. That wire moved. The wire that I said won't move moved. Alright, so now connecting the fan just means that it gets moved to a different spot, and it should work. That had to happen. Alright, they tacked on. Just realised what I did. Put the fan positive on the collector. No, that's not going to work. Fan positive needs to go on the positive rail. Alright. Fan negative will go to the collector. I'm just going to solder one of the fan wires on the collector and then solder the other fan wire to that fan wire. I'm just bodging them on for testing purposes, that's all this is. I'd obviously never install something like this. Alright, let's see if I have fixed the problem. I always got to check if I hear a spark like that it's, you know, just the cap charging up and not something that's gone terribly wrong. Just realised I bent that regulator over. Alright, let's see what we got now. Well, that definitely works. I think I'm going to want to increase the value of this 2.2K resistor a bit. Now, let's do a bit of a test. Let me turn that off. Wrong multimeter. Got to get a multimeter that does temperature. I'll get this big one because it's got a big screen for you guys. Now, don't expect this to be accurate. It's going to be off by a couple of degrees, but only a couple of degrees. When I say a couple, between 2 and 6 degrees, something like that. You know, not a great deal. This is just a thermocouple I've made myself. It was an old one, and for those that don't know, one wire is aluminum and one's chromal, and you can twist the two together, and where they first touch, that forms a new junction. You can solder them together, twist them together. The best way to do it is to use a spot weld them together. But there's a lot of different ways you can do it. Temperature. Yeah, no, it's that one. All right. I want to see what the temperature is with me holding this off at a distance, basically. I am definitely going to want to increase the value of that resistor. 100%. Let's see what temperature. I'm going to have to do this slowly because we need to wait for the actual NTC to warm up. It seems like 70 degrees roughly is the turn on point. Well, it could be a bit lower. Even that's not very fast though. Yeah, okay, so I'll just move that off to the side for a minute and turn it off so it doesn't go flat. Let's do that now quickly before I start getting these boards on the transformers. I think I'm just going to replace it with a pot, to be quite honest. Although it's going to be kind of hard to fit a pot in there. Let me think about this. I've got a few ideas. Let me just think which of the few ideas, or should I say solutions, I want to choose. Alright, I've had a bit of a think, and what I'm going to do is I'm going to get a pot and see if I can fit it between the trace there and the ground plane. Have a wiper, one end of the track and the wiper on the ground plane, and the other end of the track over there. If I can't get it to fit, I'll just solder a couple of wires onto the board that go to a pot, and then when we build the amp, I will dial the pot in situ to the right resistance, take the pot out, measure the resistance, and then fit to the appropriate resistor last minute. I think that's what I'm going to do. But if I can fit the pot in there, although you know what? No, because I don't want a pot in there anyway. I'm just going to solder a couple of wires on there. We just take these resistors off, and I'll solder a couple of wires on there. See, the thing with this amp is, the heatsink's got to run really cool. Now, it's still doable to get 250 watts out of it, but the heatsink has to stay around 50 degrees at full power. Not at halfway, it can get hotter, and it will get hotter because at half power the transistors will be dissipating the most. But at full power, the heatsink needs to be around 50, 55-ish degrees, something like that, at the absolute maximum. It is, I have taken measurements of the heatsink, and it is on the biggest size of heatsinks that you would get for a 251 amp, so that's good. But I do remember when I built this amp years ago, I did get that power out of it. Here's the strange thing. I ran it with no fans, and I remember the heatsink was quite hot, with me driving the absolute crap out of it, and I didn't blow transistors, surprisingly. They were definitely over their safe operating area, so that's amazing. But I remember putting a fan on it, just one fan, and I remember it running very, very cool. So I'm thinking I might actually go with 2 fans, just purely because of the temperature I need it to run at. But yeah, it remains to be seen. I wouldn't be surprised with 2 fans and the size of the heatsink I've got that I can actually get rid of the heat that I need to get rid of. I mean, at worst case scenario, I need to get rid of, say, 125 watts of heat per channel. So 250 watts per heatsink. That is doable, but I would imagine that I'd be around 60, 70 degrees Celsius, not the 50, 55 that I want. So we're just going to have to see how this turns out, you know? Absolute worst case scenario, it's still going to do a little bit more than 200 watts safely, but I'm hoping to get 250 out of it. Let me show you something. Let's get my computer powered up. I'll have to pause the video again. Alright, the computer's started up. You know what, I'm not going to bother soldering 2 bits of wire onto these now, because I'm sure everyone's noticed. Well, let's just take this apart first. I basically have been getting all the boards ready so that come what I'm going to call building day, I literally just have to wire everything up. So I'll just do this on said building day. There's no point in putting wires on 2 of the boards and not having wires on any of the other boards, you know what I mean? Also, I need these thermistors off of here too, because I have to mount these to a heatsink. I can potentially use a different style of thermistor. I've still got to do the bodge wire on that one. Let's call it a jumper wire, it sounds better. There's a tip for you all. If you want your project to sound like it's designed a little bit more professional, in a professional manner than what it actually is, don't tell people there's a bodge wire on it. Tell them it's a mod wire or a jumper. Anyway, yeah, so I could use a different style, but I'm probably going to use them because I don't know if anyone that's watching, or should I say everyone that's watching, is aware of this, but NTCs don't have a linear temp curve, and different NTCs have a different temperature curve. Now, I'm not saying that it's, you know, like it goes all over the place, but it's not exactly straight up, you know, it sort of has a bit of a curve to it. It picks up at the end, or it picks up in the middle and then slows back down at the end, and different devices have different curves. These devices have a very, very linear curve. I mean, some NTCs, the curves, that annoying that the circuitry has to be slightly adjusted for it, and it doesn't work exactly how you want it. These, I find, work. There's no comparator, there's no reference, there's nothing it's getting compared against. It's just this with some resistors to bias a transistor, and this just applies more current to it as it heats up, and that turns another transistor on. It's a very simple circuit, and this is the only NTC out of, let me just show you all the different types I have in my collection. I know I've got more than this somewhere else. I mean, I've got these in 2 different values, but I mean, other than these couple of spares that are in here and these ones, I know I've got a pile of these somewhere. These are for ACs. This this is like a wet bulb measurement. This is a dry bulb. I think it's the other way. I always get these 2 mixed up. One of these, this one senses outside air temperature. The other one senses the coil temperature. Anyway, I've got whole loads of different little temperature sensors, NTCs, that I've collected out of things. All different styles. Some are NTCs, some are I can't think what they're called. Using some sort of junction technology. Anyway, there's actually more than what it looks like here. You'd be quite surprised in every form factor you could think of, other than like TO220s and stuff like that. I mean, that one can be mounted. But anyway, I've experimented with a lot of different types of sensors like this. I haven't played around with these little ball ones because I'm pretty sure that they're just Uralume or Chrome melted into a ball. It's like the same as what I was just using with the multimeter. But I've experimented with these and the coloured ones and things that you can mount and have metal bodies. I've tried all of those and I found that, believe it or not, these ones are the best out of all the ones I've got that have the most linear curve. That's why I keep using them. I haven't experimented with the 20 ohm version of them, only the 100k version. Jaycar sell a few different values and I wanted some 100k versions and I wanted some lower ohm versions for, you know, some sort of circuits I might build that require a lower ohm version. Like just as an example, some low powered thing where the thermistor is actually supplying the current to the device and you just need it to drop in resistance a bit and it's a lower value or whatever, you know. Like I can't think of an exact scenario right now, but anyway, that's why I bought the two values and I've only played around with those so far and I found them to work a lot better than the ones I had in my parts bin. So that is why I am using those. Even though it's annoying to mount them to a heatsink, it's because they seem to perform really well. Next time I am working on my power supply that I'm building, I'll show you guys the NTC I've got in there. It's a different style and it's very obvious. It's the same circuit it's using and it's very obvious the temperature curve is completely different. It's very sudden compared to this one. Anyways, and I can't remember if I've mentioned it in previous episodes, but it turns out that these are 100k. I've thought for the longest time they were 120k, but it turns out they're 100k. I was looking in the catalogue the other day and they're 100k. I've moved these two wires, so I'm going to go put these boards off to the side and these. Something just occurred to me as I was packing that up. I meant to show you guys something on the computer before and I completely forgot about it. So let me just put these two resistors away and then we'll do that. Alright, this is that PA amplifier that the heat sinks and transformers came out of. I owned this and I had overloaded it in the time I owned it many times, pulled more than 250 watts a channel out of it at ridiculously low impedances, like, you know, 2 ohms, around that ballpark, something around there, 2-3 ohms. And I never had a problem with it. And when I started looking into the data sheets of the transistors that I'm using for my amps now, plus the transistor data sheets of the transistors I used for the original build years ago, and then I had a look at the data sheets for the transistors in here, and I've got to show you guys something, because as far as I can look over the entire internet, everybody's general rule of thumb, and it's true, but it depends on the temperature of the transistors, right, is that, you know, if you're using, say, a 250 watt transistor, you can use 125 watts of power output from it in an AB output stage. Well, that's complete BS, and I'm going to explain why. Now, this thing never blew its outputs, and it's got 238 C3856 GY. Oh no, Y, yeah. So 2SC3856 and 2SA1492. Now, let me see if I've got the data sheet. I should do. Uh, 2SA 1492, isn't it? 14. I've got the window in the way. Alright. A1492. C3856. Wait, what? Hold on. Something's not right here. Alright, so I got it up. So the transistors I was going to use, okay, let me explain something first. The transistors I was going to use are bigger than the ones that were already on the heatsink. I had on the heatsink C5200 and A1943, and I was going to use 2SC5200 and 2SA1943, which are bigger transistors rated at 17 amps in a TO247 package, not a, no, not TO247. Is it TO3P? Oh, I always get them mixed up. Anyway, the transistors I originally built the amp with were the smaller ones, which are the same case as this here, and the same case as the ones that I have on there now, the 0302s and 0281s. Now, the ones I'm using and used and have on there now, and was going to use, are all 150 watt rated parts. These transistors here are the original ones from this amplifier, and they are rated 130 watts. And yes, they're only rated for 15 amps, 180 volts, 130 watts. A lot smaller transistor. Now, if we have a look at the safe operating area, let's see if there's anything else. Here we go, PC temperature ambient derating. Oops. This is the part I want to look at the most. 130 watts at, the usual 25. If we come up to, say, about 50, 60 degrees, we're only at around 100 watts. That's still actually quite respectable in terms of power handling. I'm not going to lie, but especially for a smaller package, but you'd still be surprised. But there again, these heat sinks, especially fan cooled, can run really cool. So what you have to remember is, on a smaller heatsink without fans, it might be up here near 75, 80, 100, it could be over 100. With a huge heatsink with fans, you might have at 50, 60, whatever degrees. So I still am surprised that they have these transistors in there. It doesn't seem right to me. It seems way too small for a 250 watt channel to only have two pairs of this. I mean, let's do the math on this. Each transistor needs 125 watt dissipation, which would be 30 degrees C, roughly. I mean, I find that hard to believe. I don't know how they handled it, but they did. Bloody good transistors. I do get the audio's dynamic load, and, it's not like playing a sine wave through it, but, man, that is amazing to me. I wouldn't push my luck that much. I mean, I'm already pushing my luck with this. I've got, here they are. This is the data sheet for what I've put in there. Now, these are only 15 amps, 150 watts. A lot better, but if we come down and look at the power dissipation, case temperature, right? Around about 50 degrees, we can do 120 watts. This is why I say 55 degrees, because basically at 55 degrees, it's probably actually, 50. Maybe a little bit less. I need 125, so actually, I'd say right on 50 at the most, really 45 degrees. It's going to be right on the edge, but like I said, I didn't have any problems with those other transistors in the amp already, and I used it for years, abusing it, used it as a sub amp, running dual voice coil car subs on it. you know, and it never gave me any problems. So we're just going to see what we can do. Anyway, let's get on with these transformers. So what I've done is I've taken that scrap of tape around the middle. Oh, and I've got to mention this too. Someone left a comment saying that this band that's going around here is acting as a shorts. Well, no, it's not. The windings have got to go around in this direction. Anything that's going in the opposite direction is not shunting the field. The field that you're thinking about is going in this direction, not this direction. The other thing I want to point out is a common misconception about laminated transformer cores. Doesn't matter if it's one continuous laminated sheet that goes around and around and around in a spiral, or if it's made up of E&I cores, or what it is. Go get a brand new transformer from a reputable manufacturer. Go get your milliohm meter or whatever and test it for yourself. But I can guarantee you all of the laminated sheets are shorted together. Yes, the lamination is there to help with eddy currents, but it only helps, and the secret is in the word help. So basically around the edges where it's cut and where there's imperfections in the metal and such, it just shorts all together and touches. Once it's all sandwiched up, it just inherently shorts out. There is a lot of area that doesn't touch because of the lacquer, the lamination, but unfortunately it all does short out. It just helps because it's not all one solid mass. So most of the area inside the two pieces, so like imagine these tweezers are the two pieces, most of this area inside here, the lamination, whatever you want to call the stuff that's covering it, it stops the metal from making metal and metal contact. But the edges, where there's little imperfections and stuff, it's all shorting. So it only helps. I just want to point that out. Yeah, you've got to play around. You've got to wind a lot of bloody transformers to start picking up on these things. It took me years to work out a lot of the stuff I've worked out, and it took me those years just from playing around building stuff. And it's, yeah, you end up discovering stuff that you wouldn't have otherwise thought about. I can tell you that. But yeah, go test it for yourself. You'll be quite surprised. The insulation just merely helps. It doesn't completely stop the bits of metal from making contact. Anyway, what I'm going to do, because I can move these, I think I might rewrap this or something. It's not dirty, it's glue. So I can't clean it off. It just looks yucky because it's brown. And there was some sort of cardboard, see that brown stuff there, that paper? There was some of that all over it, and I peeled it off, and all the glue stuck to it and made it even messier than what it was. So I can't really do anything about that other than, I mean, I could cut all this tape off and rewrap it, but I really can't be bothered. It's a little bit dusty too. Honestly, I did give these a bit of a wash off with some solvent and a wipe down, and nothing really came off, so I'm just going to leave it how it is, whatever. But what I'm going to do is I'm going to bend all these in, trim them all up, and solder and heat shrink wires to them. Actually, you know what? I'm going to leave that to assembly day this end, because I'd rather cut all the wires to length inside the amplifier, not, you know, like just guess a length now and then cut it shorter again on the build day. That's just wasteful. I'm just wasting wire there. I'll just bend these in very carefully. Don't want to create crease points, because then I will have to rewind it. Alright, do the same thing for the other one. And on this end, what I'm going to do, I already said this in another video, but basically going to solder all these wires over to the board. Should do it off the end. I'm gonna pause and have a little think about this because I wanna do it in the best way I can do it. I still haven't even worked out how I'm going to mount these. These aren't exactly like a Toyota transformer where you can put a bolt through the middle and it comes out the bottom. They don't have brackets like a EI core that you can just screw down to a case. It's just a weird shaped lump of something, or copper and steel, that I don't have brackets. I don't know what the brackets look like. It's such a weird shape. Alright, against my better judgment, I think what I'm going to do is, in the case of the amplifier, because I am going to get a case for them and I am going to put them in separate cases. I've decided upon it finally. I think I'm just going to put something that's, you know, like silicone or rubber that's sort of like a square shape in the bottom, and put this on top of that for vibration absorption. I'll probably cut 2 smaller pieces and glue them to the bottom and stand each one of these on those pieces so that I can have air holes underneath in the case around it for air to come through. I'm not sure, I haven't thought about it yet, but and then I'll probably just drill a hole there and the other side of this piece in the bottom of the case, and the same here, and just loop a cable tie around each end, because I don't have brackets for these and I'm not going to make brackets for them. Yeah, so considering that, I think what I'm going to do is just strip these a little bit more, neaten them up. I don't want to cut them too short. There again, it doesn't bother me too much if they're short, because the whole idea of having this board here is so that in future, when I decide I want to reuse the transformer for something, if I ever do, I don't have to keep cutting and rejoining this wire that's getting shorter and shorter and shorter. I can just solder a wire onto this strip and desolder it, you know. These wires will just stay permanently on the strip. So I'm just going to get on with that. I'm not going to bore you all with me cutting it up and prettying it up. I'm just going to pause the video, prep up all the wires, and get on with it. I'm going to prep these copper ones too, so that come building time, it's just ready to assemble, and I'm going to heat shrink these two. I'm also going to, is that cracked? I've finally come across a cracked solder joint that I did myself. Oh no, it's just a scratch line in it. Fair enough. I was going to say, I'm pretty sure I soldered that together because I tried investigating this a while ago. Incidentally, this is hilarious. I don't know if I've mentioned this in another video or not, but I finally remembered how I managed to fry 2 amplifiers at the same time. It was these transformers. I ran into this problem years ago and tried to run these off another transformer to boost their voltage. And that's why I powered them both up at the same time, because they were still wired up to the boost transformer. And when I turned it on, these both came on and both amps went up in smoke. I finally remembered how I did it, because I thought that was odd of me to do that. And I still find it kind of dumb that I still didn't disconnect one of them, but oh well. Lesson learnt. Okay, I've cleaned up. Sorry about that. Let me just get this to lock. Right, I've cleaned up everything. I've trimmed everything to length and re-tinned everything, ready to accept heat shrink and wires. Same with this end. I've twisted all the wires up and cut them. I've just got to tin them and solder the strips. So without further ado, I'm going to do that. As soon as this is done, I'm going to leave off this video here and upload it and get to work on the next video, because guess what that is? Yep, it is designing the front end for this amplifier, and the video after that will be testing the amplifier. So I'm probably a day or two off of what my goal was, and if you include putting in a case, I've still got to get a case. That could be, you know, a couple of weeks off, but I'm getting there. I guess the manufacturer that made these transformers ran out of wire on this one, because this brown wire is thicker than all the other ones on the 15-volt winding. All right, fairly happy with that. Okay. Oh, I haven't soldered these. Whoops. All right. Okay. I think it's going to be easier if I turn it around. I'll just move one off to the side for now. Turn it around and sort of hold it, yeah, like this. Okay, that's 2 down. I think this is working out quite nice, actually. I like it when things go to plan. Do you like it when things go to plan? Yeah, that's good. I like that. And then I've got this half area on each thing to solder a wire as many times as I want without ever having to touch this again. So that's why I've done this, if anyone's wondering. As soon as I've done this, I'm going to tape these 2 halves again in the middle like I had. That's soldered? I didn't solder these 2, did I? Oh yeah, they're tinned. All right. This really is working out well. That's good. Ow. Alright. That's the first one almost done. Bloody beauty. I can't complain about how that's come out. Honestly, I'm not going to lie, this has worked out better than what I was expecting it to. I'm really happy with that. Oh, not what it does when you touch it. You know, that's solid as too. Bloody hell, that's great. I'll just tape these two together. I mean, it's going to be mounted in the bottom of the case, so it can't be moved around either. But that's a lot better than having the wires flapping around and getting shorter every time I solder another bit of wire to it, you know. Let me just go get that tape. All right. That's one of them prepared. Yeah, that's where they go. That's nice. I'm pleased with that. All right. I'll put this on the table with the rest of the parts. I'll give you guys a look at that soon. It's actually starting to look pretty cool. I'll get this one done off camera and just come back and show you when I'm done, so I don't waste your time. I should have cut that a bit shorter, eh? I'm not going to bother, I'm just going to leave it. It's not, you know, it's not the end of the world. You can just have it like that to even it out, that's fine. And that doesn't electrically change it, so, you know, doesn't bother me. Alright, I'll go and get this soldered up and I'll be back in a minute. Yeah, well, that was a bit of a miserable failure, wasn't it? I'm sure you're all looking at me going, you forgot it again. Yeah, I'm good at forgetting things, I know. Goodness. And the capacitors are literally right there in front of me. In my defense, they were hidden behind a giant transformer. Goodness. Anyway, I'm going to now mount these. I'm just going to fold the legs in, cut them and put them directly on top, like so. These caps are 400 volt rated. I don't see even a 10 millisecond spike reaching the 400 volt limit. That's why I chose these as the suppression caps for the transformer, just so if a power on, you know, you turn it on not on the zero crossing point of the sine wave, you know what I'm trying to say. And it tries to make a really inductive kickback. It doesn't slowly break the capacitor down, either in value or turn it into a short inside, because either of those two things can happen with capacitors. Obviously it depends on the type of capacitor, but all right. I might put these back on a bit of an angle, like that. Yeah, I like that. That's nice. Yep, I'm happy with that. The trick there is to melt just enough solder to get the capacity into the solder without melting enough for the wire to come off the board, and then you've got to hold it in position again. Anyway, that is one of these done now. So now I'll go put this back away and I'll get on with this one. Try not to forget this time. Capacitors. Alright, that's the power transformers made up. Just move this over so you can get a good look at them. So, on to preamplifier design. That concludes this video, but what I'm going to do is I'm just going to move these over and show you what we've got so far. So this is what we've got so far. 2 transformers, 2 output stages, 2 cap banks, 2 rail fuses, input fuses, protection and filtering for the line, speaker jacks, bridge rectifiers, inputs, power switches, NTCs, pots to determine the resistor values for the fan controllers, 2 fan controllers, 2 driver boards, 4 fans. Quite a lot of stuff. It's actually starting to look like something. And a nice little space there for 2 preamp boards. There's only one other thing that I still have to address, and that's this. I wanted to add windings to this. Can you see why that's not going to happen? Somehow I don't think I'm adding windings to it. From what we saw, it looked like we had the correct rail voltage anyway, so you know, it managed to run 2 fans without the voltage dropping, and the rail voltage was 47 or 48 volts, which is what we need. So I don't need to add more windings. You know, if you can't tell, I like overdoing stuff when it comes to audio. Just a little bit. So it'll have to suffice. It'll be alright. Alright, that's it for this video. Thanks for watching, and I'll see you all very soon. Bye.